So in this question, you can see a transverse wave obtained by oscillating the ball in a vertical direction. We noted that the direction of the wave is moving towards the right. In part A, you are to determine the amplitude of the wave. So the arrow drawn over here shows double the amplitude from a crest to a trough position. So when you're measuring the distance, please measure it to scale. You might get a different answer based on the printout, but as long as you recognize that this distance over here, this height over here is double the amplitude, you should be able to get the correct answer. In part B, this distance between a trough to a trough, or you can also use the distance between a crest to a crest, or the distance between this rest position to the second rest position, skipping one rest position. All these are distances that represents the wavelength of the wave. In part 2, if you're given that the ball oscillates 40 times in 60 seconds, to convert this into a frequency, which is the number of oscillations in 1 second, we can just simply divide 40 times across 60 seconds by 60. So if you use 40 over 60, you will be able to get the number of vibrations in 1 second. And this is how we can obtain the frequency of the wave. What remains to be done is to use a wave equation and to plug in the values for frequency and wavelength to get the wave speed. Finally, in part C, this is how we can describe the motion of the particles in a transverse wave. The particles in a transverse wave move perpendicularly to how the wave travels. So in this scenario, since the wave is moving towards the right, the particles are moving in a up-down motion.